In part 2 of today's lesson, we'll continue factoring some quadratics where we have to factor first and then solve, and then we also have a word problem involving projectiles. And so let's take a look at these three problems, and they're similar to what we were doing in part 1 where we have to factor first. The tough part about this one is that the outside terms and inside terms are going to end up subtracting this time to make a negative 4x. So as I think about the numbers, I'm thinking of numbers that multiply to make 12, but they subtract to make 4. So I'm going to use 6 and 2, and I want them to subtract to make a negative 4, so I'm going to make a negative 6 and a positive 2. And remember, this all equals 0. So this factor here, x minus 6, if I could just figure out the value of x that makes this 0, doesn't matter what this other value is, 0 times this number is going to equal 0. So that's what we're trying to do here, is find the values of x that make it 0. And so I set both factors equal to 0 to do that. And so in this case, I need to add the 6 to both sides, and over here I have to subtract the 2. And then from there I get my two values. So x equals 6, and we have x equals negative 2. And so we have our two solutions, our two x-intercepts, our two zeros, our two roots, lots of different ways to represent the answer. Next problem here, looking for two numbers that multiply to make positive 10, and they add together, because they're the same sign, to equal 11x. And so we go ahead and put in our two binomials. We know both signs are positive, so we just put in our x for x squared. X times x makes x squared. Now numbers that multiply to make 10, but add to make 11 are 10 and 1. From this point, we take those two factors, set them equal to 0 to find out what values of x make it 0, so that when we go ahead and multiply one of the factors by the other, we'll get 0. And so that's what we're doing here. We're subtracting 10 from all sides for the one on the left, subtracting 1 on all sides for the one on the right. So x is going to end up equaling negative 10. Over here, x equals negative 1. So those are the two solutions, negative 10, negative 1. The two values that make this statement true. See, negative 10 plus 10 equals 0. Negative 10 plus 1 equals negative 9. And 0 times by negative 9 does equal 0. So that's why negative 10 works. Negative 1 works because if we put in a 1 for x right here, we have negative 1 plus 1 equals 0. And negative 1 plus 10 equals 9. And 9 times by 0 does equal 0 as well. This next one here, we find two numbers that multiply to make 35, but add to make 12 would be 7 and 5. Both signs need to be positive because they multiply to make a positive and add to make a positive. So in this state, we go ahead and take those two factors, set them equal to 0, and we go ahead and solve. So here we're subtracting 7 from all sides. On this other side, we take away 5 from all sides, and we come up with our answer. X equals negative 7 for one, x equals negative 5 for the other. So there it is, negative 7 and negative 5, the two x-intercepts. Two solutions, two roots, two zeros. Well, here's an interesting problem. We're trying to use these quadratics to give students an idea about where they're used. And so here's an example. Quadratics oftentimes are used to represent a projectile, an item that is projected into the air, but then the only force that's bringing it down is gravity, and that's what's happening here. So the height of a flare is fired from the deck of a ship in distress can be modeled by this expression. And a little background here, 56 right here represents the height when t is 0. That means it started 56 feet up. So the deck of the ship was 56 feet above the ocean. And we also have an initial velocity right here, 104 feet per second, is depending on what they're using for their distance, but it should be feet with the value that they're using, because the way they come up with this is it's 1/2 the acceleration of gravity, which is feet per second squared. Feet per second squared, the acceleration of gravity at sea level is 32 feet per second squared, about that at least, and so they're getting this number because they're taking half that value, and the opposite as well. Well, what I would do is what they want to find out is the time it takes the flare to hit the water. Okay, time to hit the water. That means water is at h equals 0, a height of 0 feet. That's where it's going to end up landing. So that's what we're going to do here. We're going to take that 0, or h, and put 0 in place of it. Now, when I look at all these terms here, negative 16t, squared. I look at positive 104t. I look at 56. Look for a factor that goes into these numbers, because we need to factor this, and this is a tough factoring problem. So one of the strategies that we talked about earlier on was look for common factors. Another one is to get rid of that negative sign out in front of the t squared term in this case. Well, if you look at them, I would try 4 first, but then when I tried 4, I saw that this was another even number. They were still all even numbers, so I could take out another factor. I'm going to take out 8. And I'm actually going to make it negative 8. Because when I took out a negative 8, here I'm left with the negative 8 on the outside. I do the division, I've got 2t squared, positive 2t squared now. It becomes a negative, and this makes a negative 13t. And over here, I have a negative 7. So on your problem, always look to see if you can take out a common factor. It'll make the factoring much easier at the end. Well, from this point, now we need to factor this trinomial. So I'll just bring this negative 8 down. It doesn't really affect the problem at all. All it does is affect the graph, not the solutions, not the x-intercepts. So now I can start with 2t and t. And I also know the only numbers that make 7 are 7 and 1. But I need to look at that outside, inside terms, what I'm supposed to be doing with them. And since it's a negative 7, it means I'm going to subtract the outer and inner terms. They're going to make a negative 13t. So if I put 7 here and 1 here, I can get those outside terms and inside terms to subtract to make the 13. And in order to make it a negative 13, I'm going to make the 14 negative, the 1 positive. So the plus sign would go here and the negative sign here. And so from here, what we're going to do is we're going to use that zero product property. Because remember, all of this all equals 0. Well, since negative 8 doesn't have an x value, we don't have to do anything with that. All we care about are the values, the expressions that have the variable. And I said x before, but here we're using t. So I'm going to use these two expressions, and I'm going to set them 2t plus 1. I'm going to set them both equal to 0. So 2t plus 1 equals 0, and t minus 7 equals 0. And we're going to find the two values that make this statement true. So we go ahead and work this first one, and I have to subtract the 1 from both sides, and I end up with 2t equals negative 1. So I divide by 2, and there's my answer. T equals negative 1/2. Over here, I end up with adding 7 to both sides, and I end up with positive 7. So let's take a look at our answers here. Remember what they're asking. They're asking for the time it takes the flare to hit the water. Well, let's just think about those answers here. We have one answer that's negative 1/2 of a second. Another answer is 7 seconds. Negative 1/2 of a second. This means it occurred before launch, before it was fired into the air, before fired in air. And so this answer doesn't make sense. This we call an extraneous solution. So we're going to cross that one off, not use that one. We're going to go with this answer right here, 7 seconds, because it's the one that makes sense. Why do we have two answers? Why is one that we're not going to use? Well, here's the reason. If we just look at the graph real quick, just an expression of what that graph looks like. We start up at 56 feet. That's what I mentioned before. This is the starting point. This is the y-intercept. And what we did is we fired this into the air. It's a negative 16t squared, so it makes an upside down parabola, and it ends up going up and then hitting the ground, or hitting the water. And so this is the level of the water right here, water level. And this axis represents time. And so what happened here, the reason why we have one answer of positive and one answer of negative is that if we extended this graph, it would continue to go off in this direction. Over here, it would continue to go off in this direction. And eventually, it crosses the x-axis again here at negative 1/2. But this part here in blue doesn't actually affect the problem. We don't use that. All we use is the part in green. So the part in green is really what's taking place. See, at 56 feet, it was launched into the air. It gets up to a maximum height at some time, and then it falls back, and it hits the water at 7 seconds. And that's all we really care about. It's all that we had in the problem. And we just wanted the time it would hit the water, and that's 7 seconds. So there it is. So factor first, then solve using that zero product property. Good luck.